Today we are going to go over 9.5 part 3. How do we find the polar areas between curves? The area formula is 1/2 integration from alpha to beta r squared d theta. This gives us the area bounded by the polar curve and the rays theta equals alpha and beta. Let's have a look. Given any two curves, how do we find the area? Let's have a look at example 1. Find the area between the two loops for the graph r equals 1 plus 2 sine theta. If you graph this into the calculator, the function will look like this. And the area between the two loops, we are looking at this region. So this will be the area of the outer loop minus the area for the inner loop. Let's have a look. The outer loop here minus the inside, the inner loop here. Okay, so the outside loop here, it's 1/2 integration. A lot of students will put 0 to 2 pi r squared d theta here, minus 1/2 integration, as we calculated this before here. If you set this equals 0, this gives us 7 power 6 and 11 power 6 over 6 r squared d theta. So for the first one, 0 to 2 pi is not right, because if you go from 0 to 2 pi, it will cover the inside loop twice. That's why we have to change the boundary from 0 to 2 pi. We are going to start from here and go all the way here and come back. We can use negative power 6, which is 11 power 6, to 0, then to power 2 pi, to 7 pi over 6. Be careful here. Don't use 0 to 2 pi. And this gives us the area, which is 8.3377. Let's have a look at example 2. Find the area inside of the loop here and outside R2. Let's draw a picture. So this gives us two circles. This is R1, this is R2. We are looking for the region here, inside R1 but outside R2. This is the shaded region here. You can do half and multiply by 2, okay? Or if you look at here, if this is our ray, as the ray going first, it will reach point A and then it will reach point P and point B here. So if you look at the area as R follows R1 from A to B, that will give us the area between the two rays and the curve. And if we follow R2, which is the purple circle, from A to B, it will give us the area here. So the purple one, AB, is the one from here to here, which is from here to here. So we have to do the subtraction here. So first we find the point for A and B, which we call theta 1, theta 2. We set them equal. So 3 sine theta equals 2 minus sine theta. So sine theta equals 1/2. So give us power 6 and 5 power 6. So our area will be 1/2 integration theta 1, theta 2. This is R1. This is R1 squared d theta minus 1/2 theta 1, theta 2, R2 squared d theta. We can combine them because all the boundaries are the same. This is R1 squared minus R2 squared d theta. We can put this into your calculator, give us 5.196. Let's look at the next example. Find the common area interior for this and this. I'll call it R1 and R2. You plot this into your graphing calculator. 1 gives us a circle. The other one gives us heart this is R1, and this is R2. And the interior region will be here. So if you look at this region, the shaded region is symmetric about the x-axis. So we can do half of it and multiply by 2. We are going to do here, a region here, and multiply by 2. Okay, so if you look at this region first, if we draw a ray, we will first follow R2 and reach point A, and that's the region covered. And then it will follow this is R2, and then we'll follow R1, which is a circle. So this is point A, R1, reach here. We just add the area together. So first, if you look at R2, theta equals 0 here. And for point A intersection, 3 cosine theta equals 1 plus cosine theta. So theta equals pi over 3. And for R1, this is pi over 3. And here, R equals 0. So theta equals pi over 2 here. So the area will be 1/2. 0 to pi over 3, R2 squared d theta, plus 1/2, 3 pi over 3 to pi over 2, R1 squared d theta. And don't forget, you multiply by 2. Our final answer is 3.927. These are the polar areas between curves. Next, let's have a look at the arc length of the anypolar curve. So given r equals a function of theta, this is polar graph, and theta is between alpha to beta. The arc length between alpha and beta is given by integration alpha to beta r squared plus r prime squared d theta. Let's have a look at this function. Given r equals 2 minus 2 cosine theta, and this is the graph, theta equals 0 start from here, and when theta equals pi over 2 pi, it will come back. So the arc length of the whole picture will be 0 to 2 pi, integration 2 minus 2 cosine r squared plus r prime, which gives us 2 sine theta squared d theta. When we put this into a calculator, give us 16, which is a very nice number.